Welcome to Cookie's Maths and Science Hub. Today we'll be looking at how to sketch circles using the standard form and converting to that standard form in some more complex problems. Given below is the standard form of circles when sketching them on the Cartesian plane. When written in this form, they are quite easy to sketch and follow some very basic steps. So we have x take h, where h represents some sort of integer, any value. So x take h squared plus y take k squared equals r squared. The k also, like h, representing any sort of integer value. The r represents our radius, which again can be some sort of value. And the h and the k give us our center coordinates for our circle. So this gives us hk or xy, so your xy coordinates for the exact center of your circle. Given that we have that, and we also get our radius squared, all we need to do is take the square root of our r squared, whatever value that might be, and then we can use that information to draw a circle on the Cartesian plane. You can see how we translate this information from the equation here onto the Cartesian plane. So we've taken our center coordinate, hk, and then we've used our radius. That's not r squared, remember, you have to take the square root of that value at the end of your equation to get your radius. And effectively, we've gone out from our center coordinate in 4 directions, and then we've just used that to draw the circle on our Cartesian plane. It's pretty straightforward. Let's look at a few examples now, and then make it a little bit more complex, just converting back to that standard form, and see how we go graphing these on the Cartesian plane. So, in our first example, we've been asked to graph x plus 1 squared plus y take 1 squared equals 4. Now remember, as I said, those h, k, and r values are substituted in for numerical values or integer values. So we know our center point is our h and k values. But remember, in our initial equation, it's x take h, y take k, meaning that we need to find the inverse, or effectively the counter. So if we have 1, it's -1. If it's -1, it becomes 1. So in this point, in this equation here, our center point is going to be -1 for our x value because it's x plus 1, so it becomes -1, and just 1 for our y value because it's y take 1, so it becomes 1 in this case. For our radius, we have 4, but you've got to remember that's our radius squared. So we take the square root of 4, which in this case just equals 2. Now, let's look at the graph for how we might graph this equation. So the first thing to always do is place your center point. So we know our center point is -1, 1. So we're going to place that on our graph, just right there. Now we know our radius is 2. So all we need to do is go out from our center 2 values in every direction to draw the circle. The easiest way to do this is go in the 4 directions and then link it up with a circle. Now I'm obviously using nice software. I'd recommend you use a compass if you want your circle to be exactly symmetrical. So I've gone out 2 to the right, left, up, and down. Then all I'm going to do is draw a circle through that entirely. As you can see, that gives me a circle on my Cartesian plane using the standard form. Let's look at another example. Okay, in this example, we've been told to graph x squared plus y take 3 squared equals 16. Now you'll notice this one looks a little different, but don't panic. It's actually it's exactly the same, just because it looks different. The only thing that's missing is our h value. However, if our h value isn't present, all that means is it's 0. So if we're looking for the center point of this graph, we know that our 0 will be our x value because there's no h value present, and 3 will be our y value or our k value, because it's y take 3, so it becomes +3. So our center point for this graph is 0, 3. Our radius, once more, is the square root of that value on the right-hand side of the equation. So the square root of 16 equals 4. Right, let's use this information and once more graph it on the Cartesian plane. So once again, first thing we do is mark the center point. So I've marked 0, 3 here. Then we just go out, up, down, left, and right 4 units. So 4 to the left, 4 to the right, 4 up, 4 down. I use arrows. You can use whatever you want to mark it, whatever's going to be easier for you to draw the circle with. Then connecting those points with the circle gives us our circle on the Cartesian plane. Okay, this one's a bit more of a tricky one because we're told to graph x squared plus 4x plus y squared take 2y take 4 equals 0. Now, you can see this isn't in our standard form. So all we need to do to graph this one is convert it back into our standard form. Now, that might seem really tricky because we have a lot of x's and y's floating around, but all we need to do is think back to our quadratics. And if you're a bit loose on your quadratics knowledge, I suggest watching our quadratics video that goes through it and covers it. But all we need to do is complete the square for both x and y. So that's using negative b over 2a squared to solve and factorize those two simple quadratics. Okay, let's have a look at how we would do this then. So our first pair is the x squared plus 4x, and our second pair is the y squared take 2y. So for x squared plus 4x, our negative b on 2a is going to be negative 4 over 2 times 1 squared. Now, you'll see I have plus that in the brackets here on the left and also subtracted it on the right because that's what you have to do when completing the square. So we have x squared plus 4x plus negative 4 over 2 times 1 squared plus, and we're going to do the same for our y pairing. So y squared take 2y. So our negative b on 2a is going to be negative 2 over 2 times 1 squared, remembering also to subtract that on the other side as well, outside of the brackets. So our full equation then is x squared plus 4x plus 4 plus y squared take 2y plus 1 minus 4 minus 4 minus 1. We can then simplify that obviously further because we can then, take out that integers at the end. So our negative 4 take 1 obviously becomes negative 9. If we then put that across to the right hand side, it becomes 9. And you can see that's going to be our radius squared later on. So now we have our two brackets. We have our x squared and our y squared brackets. We just need to factorize them down another step. As we've completed the square, they should become perfect squares. So x plus 2 squared plus y take 1 squared equals 9. And you can see once more, we have that standard form that we require for graphing circles on the Cartesian plane. Back to the graphing. Well, we now know our center point is negative 2, 1, because it's plus 2 and subtract 1, so it becomes negative 2, 1. Our radius is just the square root of 9, which equals 3. Graphing our center point, we place our point at negative 2, 1. We go out 3 in every direction, and then we connect it, drawing a circle. You'll see the graphing part isn't necessarily the most complex of these, but can become more complex when there's lots of different factors that you need to simplify first to that standard form. Thanks for watching. Hopefully now you're able to sketch circles from the standard form on the Cartesian plane and convert to that standard form from more complex equations. Be sure to like and share this video and subscribe to the channel for further physics, chemistry, and mathematics videos. Hope to see you again soon.